we're going to be taking a look at 1.3 extension, which is absolute value equations. Okay, so let's talk about absolute value. So absolute value equations tend to produce two possible answers. And here's why. So when you're taking the absolute value of something, and I might actually do something outside of notes, so you don't have to write this on your notes. But something to consider is the fact that when you're taking the absolute value of something, so let's say I have the absolute value of 10. I have to take the positive value of whatever's on the inside. So whatever it is, I change it to positive. Since this is already positive, the answer is 10. Okay? Likewise, if I have the absolute value of negative 10, I'm going to make this positive, which means my answer is also going to be 10. So notice that you get the same answers. You get the same answer for both of those types of equations. But you had two different problems. Okay? So two different problems produced the same answer. So if I replace this 10 and the negative 10 with an unknown, let's say I don't know what the answer is. It's just x. But then I tell you the answer when I take the absolute value is 10. You don't know which one I'm talking about. It could be this problem or it could be this problem. You don't know what x is because x could be anything. Remember, x can be any number, negative or positive, right? And so you're only, the only thing you can tell me about x is there are two possible answers to x. Either x is the first problem and x is 10, or x is the second problem and x is negative 10. Okay, so notice when you're solving for x and x is inside the absolute value, you have two different answers that you could have. And that's totally fine. In math, sometimes there are two different answers to the same problem, right? That happens all the time. Okay, so let's go ahead and take some examples and see what we can do. So in other words, if a, so this is what's actually going to go in your notes, if the absolute value of a equals b, then a equals b since, a equals b or a equals negative b. It's kind of what we did before with the positive 10 and the negative 10, right? The value on the inside, the x, or the a in this case, is either going to be the positive version or the negative version of whatever is on the inside there. Since the absolute value of b is b and the absolute value of negative b is also b, right? Since both of them produce a positive answer. So I get two different answers, okay? So that's what you're going to say for your notes. It's basically what we just wrote on the sticky note. So here's some examples. So let's take an example where we have, ignore this over here. This is part of checking your problem. So let's take the absolute value of x minus 4 is equal to 6. Okay, so we have to use this logic where everything on the inside of the absolute value is either going to be equal to my positive answer or my negative answer. So I have to change this to a negative for my second possibility. So I'm going to have two split answers here. And the split happens before we get rid of the absolute value. So we get rid of the absolute value and we change it into two different equations. The first possibility is that it's very straightforward, that my answer inside here is going to end up being a positive number, which is going to be positive 6. So either it's x minus 4 is equal to 6, or the other possibility is whatever I get for x minus 4, it actually ends up being a negative number. And so the negative number would have to be negative 6, okay? So we're going to solve for both of them now. So add 4 to both sides in both cases. And so one possibility is that x equals 10, or the other possibility is that x equals negative 2. Now you might be looking at this and go, how's that even possible? Well, let's check, right? So go ahead and write this check right here. So we're going to check the first one. Let's check to make sure, can x actually equal 10 and this be true? Well, let's replace x with 10 and see if it actually works. So the absolute value of 10 minus 4 is equal to 6. So let's solve for 10 minus 4. 10 minus 4 is 6. So now I'm saying the absolute value of 6 is 6. Well, the absolute value of 6 is just positive 6. So 6 equals 6. That's true. All right, let's take the other answer and see if that's really true. So let's replace x now with negative 2, okay? So negative 2, so now I'm taking the absolute value of negative 2 minus 4 and saying that's equal to positive 6. Well, let's see what happens. Negative 2 minus 4 ends up being negative 6. Okay, so far it's looking a little dicey, but if I take the absolute value of negative 6, remember the absolute value always makes the answer positive. So now I have a negative answer, but it becomes positive 6. Positive 6 is equal to 6. So yeah, there really are two different answers for this problem, okay? And this is how we solve for it. We split them up right here. Let's do another example. Let's take absolute value of 3x plus 1 equals negative 5, okay? So this brings up a good point, or a good, let's talk about this actually. Can the answer to an absolute value be negative? Let's think about this. Whatever I solve for here, let's say I plug in a number here and I get some kind of answer. Can that answer ever be, when I take the absolute value at the end, so if I take the absolute value, can the answer ever be negative 5? Well, the answer is no. I can't get negative 5 as an answer to whatever this is. Because if I take the absolute value, I should be getting a positive answer, right? Always positive. That's the rule. Doesn't switch signs. It's just always positive, okay? No matter if this is a negative number that I get on the inside or a positive number I get on the inside, I should be getting a positive number on the outside. So this should be like positive 5, not negative 5. Since I can never get a negative answer from taking absolute value, the only thing I can say here is that there's no solution. There's nothing I could plug in for x that would actually give me a negative 5 as my answer, okay? All right, let's do another example. Example C. Okay, so what happens if we get numbers on the outside of the absolute value? So notice I have an equation on the inside, or an expression on the inside, I should say, and then there's a number hanging out on the outside. Well, the first thing I have to do is we have to solve around the absolute value first. We have to kind of treat it like there's parentheses here. And so if we're peeling away the layers of the onion, we can't touch this stuff until we've gotten rid of this negative 10 first. So we're going to go ahead and add 10 to both sides first, okay? And that's good because when we started with the negative 4, it was looking like this was going to be no solution. But when I add 10, now suddenly I'm saying the absolute value of 3x plus 9 is equal to positive 6. So I can actually solve this, okay? Now that we've added 10 to both sides. Now keep in mind, if you had a number in front right here, you cannot distribute. Do not distribute, okay? In fact, we might make that note here in a second. Do not distribute because that does not work. What you have to do is you have to divide by the number that's out front, okay? You have to get rid of that number. We don't want to distribute it into the absolute value because that does not work. Absolute value is not parentheses. It's its own thing, okay? All right, so let's go ahead and split this problem up. So our first path is to say that it's very straightforward and 3x plus 9 actually should be equal to positive 6. But then let's talk about the darker path, we'll call it, or the negative path, where 3x plus 9 could actually end up being negative 6, and then when I solve for the absolute value, it makes a positive 6. So that's my two possibilities, okay? Now let's solve for both. So we're going to subtract 9 from both sides in both cases. Over here I get 3x equals negative 3, And then over here I get 3x equals negative 15, right? And then I divide by 3 in both cases. Here I get x equals negative 1 or x equals negative 5, okay? So before we do these problems, I do want to add an example. So I'm kind of going off script here because I think it's important. So let's take as an example, let's say I've got 2 absolute value of x minus 1. I'll just make it pretty simple, equals 4. So now we've got a number on the outside. This is now saying 2 times the absolute value of x minus 1. This is what you want to do. So if you distribute, you are going to get the wrong answer. So we do not distribute. When you're dealing with absolute value, do not distribute, okay? Instead, what you're going to do, so let's rewrite the problem, is you're going to treat this like this absolute value is just a complete unknown right now, right? We don't know what it is. So we're going to treat it all as one big block together. So we're multiplying 2 things together. One of them is an absolute value problem, and the other one is a 2. So we're just going to divide everything by 2. And when we do that, this piece does not get messed with at all because the 2 cancels. The 2 cancel each other out, okay? So this changes to the absolute value of x minus 1 equals 2. Now I can do my split. Okay, I'm going to do it real quick. So now I've got x minus 1 equals 2, or x minus 1 equals negative 2. I solve for both of them, so I get x equals 3, or x equals negative 1. And that's the answer there. Go ahead and do these problems right here, and we'll come back in the next video.